The great voids of the universe. Where has all the matter gone? Have you ever looked up at the night sky and wondered if the universe is evenly filled with stars and galaxies? At first glance, it might seem so, an endless ocean of glowing islands scattered across the cosmic abyss. But the deeper we look, the more we realize that the universe is not a uniform sea of matter. Instead, it is a vast cosmic web, with filaments of galaxies stretched across space, and between them immense, nearly empty voids, cosmic deserts where the absence of matter is almost eerie. These great voids, spanning hundreds of millions of light-years, are some of the most enigmatic structures in the cosmos. The Boötes void, one of the largest known, is so vast that if the Milky Way were placed at its center, it would take billions of years for light to reach its distant edges. For a long time, these empty regions puzzled astronomers. Why are these voids so empty? What forces shaped them? And what does their existence reveal about the nature of the universe itself? The answer lies in the earliest moments after the Big Bang. When the universe was young, it was nearly uniform, a hot soup of particles spreading outward in all directions. But tiny quantum fluctuations, minute ripples in the density of this primordial matter, set the stage for everything we see today. Over millions of years, gravity acted on these fluctuations, pulling matter into denser regions and leaving other areas to become ever more depleted. Galaxies formed along the filaments of this web-like structure, while the voids, regions where matter was initially sparse, became even emptier as gravity drew more and more material away. But these voids are not completely empty. There are still a few lone galaxies, drifting like islands in an endless ocean. Some of them are strange and isolated, evolving differently from their counterparts in denser cosmic neighborhoods. These galaxies may hold clues about the nature of dark matter and dark energy, mysterious forces that govern the universe's expansion. Some theories suggest that the structure of these voids may provide hints about the true nature of spacetime itself. Could they be regions where exotic physics takes hold, where the very fabric of reality behaves differently? Could they be shaped by unseen forces, perhaps linked to the accelerating expansion of the universe? As we continue to explore the cosmos, these vast, empty voids remind us that the universe is not only a place of matter and energy, but also of great, unfathomable emptiness. And in that emptiness, we may yet uncover secrets that redefine our understanding of existence itself. If these vast voids are more than just empty spaces, if they hold hidden truths about the fundamental nature of the cosmos, then what might they reveal? Could they be the key to understanding the interplay between dark matter and dark energy, the forces that govern the universe on its grandest scales? Or do they hint at something even more profound, something yet to be discovered? Astronomers are beginning to map these cosmic voids with unprecedented precision. By studying how light from distant galaxies bends and shifts as it travels through these regions, scientists can probe the subtle presence of dark matter, the invisible scaffolding upon which galaxies are built. If voids contain less dark matter than expected, it could challenge our current understanding of gravity and cosmic evolution. Some theories even propose that voids act as testing grounds for alternative models of the universe, perhaps even clues to a multiverse, where the very laws of physics might differ from our own. There is also the question of what happens to galaxies at the edges of these vast voids. Do they experience different evolutionary paths? Could isolated galaxies drifting in the voids have formed from a different balance of matter and energy? These lonely worlds, separated from the gravitational influence of larger galactic clusters, might develop in ways we have yet to fully comprehend. And then, there's the mystery of dark energy. The force that is driving the accelerated expansion of the universe could be intimately linked to these voids. Some researchers speculate that dark energy manifests more strongly in these empty spaces, free from the gravitational pull of dense galactic structures. If this is true, the study of voids could provide crucial insights into the ultimate fate of the cosmos. Will the universe continue expanding forever, with galaxies becoming ever more isolated until all that remains is an empty void stretching beyond comprehension? Or could the very structure of these voids hint at something far stranger, that our universe is part of a much larger unseen reality? The search for answers continues, and as we refine our tools and observations, we move closer to unraveling the true nature of these vast, silent expanses. They are not mere gaps in the cosmic web, but rather windows into the deepest mysteries of existence itself. If the great voids of the universe are more than just empty spaces, If they serve as a kind of cosmic laboratory, then they may hold the ultimate clues about the fundamental forces shaping our reality. Could they be the remnants of long-lost structures, erased by time and cosmic evolution? Or are they active participants in the unfolding drama of the cosmos, influencing the fate of galaxies and the very expansion of space? One possibility is that voids play a crucial role in the balance between dark matter and dark energy. While dark matter provides the invisible framework that holds galaxies together, dark energy works in the opposite direction, pushing the universe apart. If voids are regions where dark energy dominates, they might be accelerating the expansion of space at an even greater rate than previously thought. This could mean that voids are not just passive gaps in the cosmic web, but active zones where the fundamental properties of the universe are being shaped in ways we are only beginning to understand. Recent observations suggest that voids might also hold clues about the early universe. The cosmic microwave background, light left over from the Big Bang, carries subtle imprints of these voids, revealing how matter and energy were distributed in the infant cosmos. Some theories even propose that voids could be linked to exotic physics, such as modifications to Einstein's general relativity or even hints of hidden dimensions. If gravity behaves differently in these nearly empty spaces, it could point to a deeper hidden structure of reality, one that extends beyond our current understanding. And what of the galaxies that do exist within these vast voids? In such extreme isolation, cut off from the gravitational influences of larger clusters, they are cosmic outliers, natural experiments in galactic evolution. Some of these galaxies appear older, their stars aging without the regular influx of fresh material from neighboring systems. Others, surprisingly, seem to be forming new stars at unexpected rates, defying what we thought we knew about cosmic environments. Could void galaxies be relics of an earlier cosmic epoch, preserving a snapshot of the universe's past? Or do they represent an alternative path of evolution, shaped by forces we have yet to uncover? There is also the tantalizing possibility that voids could harbor unknown forms of matter or energy, perhaps even elements of the so-called missing baryons, ordinary matter that has yet to be fully accounted for in the cosmic inventory. If hidden structures exist within these voids, they may be detectable through gravitational lensing, subtle distortions in light that reveal the presence of unseen mass. Every new observation deepens the mystery. The voids of the universe challenge our assumptions, forcing us to question whether we truly understand the large-scale structure of reality. They are reminders that even in emptiness, there is something to be learned, that absence itself can be as profound as presence. And as we refine our telescopes, our simulations, and our theories, we may yet uncover truths within these voids that transform our understanding of the cosmos forever. If voids are not merely passive spaces but active participants in the evolution of the cosmos, then perhaps they are more than just the absence of matter. Could they be the key to understanding why the universe looks the way it does today? Could they reveal the fate of everything we know? One of the most intriguing ideas in modern cosmology is that voids may act as cosmic accelerators. The lack of significant gravitational pull within them means that any object inside is essentially free-floating, unbound by the same forces that shape galaxies in denser regions. As a result, these void galaxies move at higher velocities relative to their surroundings, experiencing cosmic expansion more strongly than those in dense clusters. If this effect is real, it could provide a natural laboratory for testing our understanding of cosmic expansion, perhaps even offering insights into whether dark energy is a property of space itself or a manifestation of yet unknown physics. But the mysteries of voids extend even deeper. Some physicists have proposed that these vast regions could be windows into the fundamental nature of spacetime. If the universe is shaped by underlying quantum fields or extra dimensions beyond our perception, then voids might be the places where these hidden structures reveal themselves most clearly. The subtle warping of light as it passes through these regions could provide indirect evidence of physics beyond the standard model, anomalies that challenge our current theories of gravity, relativity, and even the fundamental nature of time. Even more astonishingly, some researchers have speculated that voids could be linked to the concept of a multiverse. If our universe is one of many, then voids might represent regions where our local cosmos simply has less interaction with others. Could the great voids be places where the fabric of reality itself is thinner, where the influence of other universes is weakest? Could they be the remnants of cosmic collisions between different regions of an infinite, ever-expanding multiverse? Meanwhile, astronomers continue to refine their maps of the universe, using powerful telescopes to probe these empty spaces with greater precision than ever before. Some of the deepest surveys have revealed faint, ghostly filaments of gas and dark matter threading through these voids, whispers of a hidden structure that we are only beginning to perceive. These tenuous filaments could be the last remnants of matter that failed to form galaxies, stretching across space like the fading echoes of a grand cosmic symphony. And yet, the more we learn, the more questions arise. If voids are truly as empty as they seem, then why do they exist at all? Why didn't matter distribute itself more evenly in the early universe? If gravity and dark energy are the architects of cosmic structure, then why do voids vary so dramatically in size and shape? Could they be shaped by forces we do not yet understand? As we stand on the edge of knowledge, peering into these vast expanses of nothingness, we are reminded that the universe is not just a collection of stars and galaxies, it is also defined by its voids. And perhaps in these seemingly empty places, we will one day find the answers to the deepest mysteries of existence. If voids are not merely the negative spaces between galaxies but fundamental components of the universe's architecture, then they may hold answers to the most profound questions in cosmology. These great cosmic gaps are not uniform. They vary in size, shape, and density, with some stretching across hundreds of millions of light-years while others remain smaller, more irregular, as if shaped by unseen forces. What determines the structure of these voids? What lies at their very edges, where the cosmic web dissolves into near emptiness? One possibility is that voids act as laboratories for studying the behavior of dark energy, an elusive force that is accelerating the expansion of the universe. In these vast, nearly matter-free regions, the influence of dark energy may be more pronounced than in denser cosmic environments. If voids expand at a different rate than galaxy clusters, it could provide direct evidence that dark energy is not uniform, but instead varies across space and time. This would fundamentally challenge our understanding of the cosmos, hinting that dark energy might not be a simple cosmological constant but something far stranger, perhaps a dynamic force that evolves over time. But voids may also be revealing a second mystery, the nature of dark matter. While dark matter is believed to be the invisible framework upon which galaxies form, it is still largely undetectable, only inferred through its gravitational effects. Yet, some models predict that voids should contain small amounts of dark matter, just enough to slightly bend and distort passing light. If astronomers can detect these distortions, they may uncover the true nature of dark matter, whether it consists of exotic particles, modifications to gravity, or something even more bizarre, perhaps even microscopic black holes or undiscovered forms of energy. At the same time, the few galaxies that do inhabit these voids are providing unexpected insights. These lonely wanderers, isolated from the dense interactions of galaxy clusters, evolve in unique ways. Some are ancient relics, their stars aging in isolation, untouched by cosmic collisions. Others are unexpectedly active, producing new stars at surprising rates. This challenges our understanding of galactic formation, suggesting that voids, rather than being cosmic wastelands, may be places where unusual, unexplained processes unfold. And yet, even as we study voids, deeper questions arise. Could these vast, empty spaces be more than mere gaps in the cosmic web? Could they be evidence of something far larger, a universe shaped not only by gravity and energy but by forces we have yet to comprehend? Some theories suggest that voids could be the remnants of early cosmic inflation, scars left behind by quantum fluctuations on scales larger than anything we have yet observed. Others propose that voids might interact with parallel universes in ways we cannot yet measure, subtle distortions in space-time hinting at an unseen multiverse. As telescopes become more powerful and simulations more refined, we stand at the threshold of discovery. The voids of the universe, once thought to be mere empty spaces, are emerging as frontiers of scientific inquiry. They challenge our assumptions, forcing us to reconsider what we know about the universe's structure, its evolution, and its ultimate fate. Perhaps in the deepest voids, beyond the reach of galaxies, beyond the grasp of familiar physics, lies the key to understanding the cosmos itself. If voids are not simply cosmic absences but crucial elements in the grand structure of the universe, then their role in shaping the cosmos may be even greater than we currently realize. Could these vast expanses be influencing the motion of galaxies, subtly steering the evolution of cosmic structures over billions of years? Could they be gateways to physics beyond our standard models? Regions where the rules governing space, time, and energy shift in ways we have yet to fully comprehend? One of the most intriguing ideas in modern cosmology is that voids might not be truly empty, but instead filled with an extremely diffuse, unknown form of energy. This leads to a radical possibility. What if voids are regions where dark energy pools, concentrating in ways that accelerate local expansion? If this were the case, voids might not just be growing as the universe expands, they could be actively pushing galaxies farther apart, accelerating cosmic separation at rates faster than previously predicted. And if voids grow faster than other regions of space, could they eventually merge? Could the expansion of voids one day tear apart the cosmic web itself, unraveling the delicate balance of structure that has defined our universe for billions of years? If dark energy continues to dominate, might the distant future of the cosmos be one in which voids expand to consume all matter, leaving behind a universe so diffuse that even atoms drift apart, lost in a sea of emptiness? But the puzzle of voids is not just about what they contain, it is also about their boundaries. Where the filaments of the cosmic web meet the edges of voids, something remarkable happens. Galaxies at the peripheries of voids experience gravitational flows that are distinct from those in denser clusters. They move differently, their interactions less constrained by the collective gravity of large structures. This means that void-edge galaxies might evolve in ways that are unlike anything we see elsewhere in the universe. Some could be unusually shaped, their formations stretched by the subtle pull of expanding voids. Others might show evidence of past collisions, brief moments when wandering galaxies met each other in the vast emptiness before drifting apart once more. And yet, even in these dark and lonely places, there is a kind of structure, a whisper of something deeper beneath the surface. The discovery of faint hidden filaments within voids suggests that they are not completely devoid of matter, but rather the last remnants of a vast, interconnected cosmic network. Could these filaments hold clues about the nature of dark matter? Are they the last traces of a primordial structure that once existed before the universe took its current form? The further we look, the more mysterious voids become. They are not just the spaces between galaxies, they may be fundamental to the very nature of existence itself. Some researchers propose that voids could contain exotic physics, perhaps even altered states of spacetime, where quantum effects play out on cosmic scales. Could these be regions where our universe interacts with unseen dimensions? Could voids serve as natural laboratories for testing the deepest questions about gravity, energy, and the fabric of reality? As we continue to refine our telescopes, launch new space observatories, and push the boundaries of theoretical physics, we may be on the verge of a great revelation. The study of voids is no longer just about mapping emptiness, it is about uncovering the hidden architecture of the cosmos. It is about understanding whether the forces that shape galaxies also shape the spaces between them. It is about questioning whether what we call nothing is, in fact, something far more profound. The cosmic voids stretch across unimaginable distances, silent witnesses to the vast history of the universe. But in their silence, they may hold the answers to the greatest mysteries of all. If voids are more than mere gaps in the cosmic web, if they are playing an active role in shaping the universe, then we must ask, could they be evolving in ways we have yet to understand? Are they expanding faster than the rest of the universe, pushing matter into filaments, like ripples in a vast cosmic ocean? Could these voids be the harbingers of the universe's fate, silent indicators of a deeper process governing the very expansion of space? One of the most tantalizing ideas is that voids may not just be growing, they may be changing the very nature of spacetime within them. Some theories suggest that the fabric of reality itself could be subtly different inside these vast cosmic vacuums, where matter is scarce and dark energy dominates. If dark energy behaves differently in voids, this could help explain why the universe's expansion is accelerating. It might also hint at a far more radical possibility, that voids are not just the byproducts of cosmic evolution, but integral to its very structure, regions where the laws of physics themselves may shift ever so slightly. Could voids be revealing the earliest moments of the cosmos? The largest voids we observe today may be imprints of quantum fluctuations in the first fractions of a second after the Big Bang, regions where tiny differences in density were stretched across billions of light-years by inflation, the brief but violent expansion that shaped the universe. If voids are remnants of this process, then studying them could be akin to peering into the deepest past, seeing echoes of the universe as it was in its infancy. And yet, the story of voids is not just about the past, it may also be about the future. As the universe expands, these voids are growing larger, swallowing the remaining filaments of matter, pulling galaxies apart. If dark energy continues its relentless push, the universe's future could be one in which all structure dissolves into vast, lonely expanses of emptiness. The cosmic web, once a magnificent structure connecting galaxies, may eventually unravel, leaving only isolated islands of matter in an ever-expanding sea of darkness. There is another unsettling possibility. Could voids be gateways to the unknown? Some theories propose that the largest voids, particularly those with the most extreme lack of matter, could be regions where space-time itself behaves in unexpected ways. In the absence of normal gravitational influences, could voids reveal subtle distortions, perhaps even evidence of hidden dimensions or interactions with unseen realms of reality? If our universe is part of a larger multiverse, then perhaps voids are where the boundaries between different regions of existence are weakest, places where the very fabric of space is stretched so thin that it begins to reveal deeper truths about the cosmos. And then there is the question of what lies beyond. If voids continue to expand indefinitely, will they one day consume everything? Will the last galaxies, drifting at the edges of these vast cosmic deserts, eventually fall into the nothingness, disappearing beyond the horizon of what we can observe? Or do voids hold secrets that we have not yet begun to imagine, forces that might one day reshape the universe in ways we cannot yet foresee? The voids of the universe stand as reminders that even in emptiness, there is meaning. They are silent, immense, and seemingly lifeless, yet they may hold the greatest secrets of all, about the past, present, and fate of the cosmos. As we continue to explore these immense and mysterious structures, we may find that they are not just voids in space, but windows into the deepest nature of reality itself. If voids are indeed more than simple gaps in the cosmic web, if they are dynamic, evolving, and possibly even revealing fundamental truths about the universe, then what might their ultimate role be in the grand narrative of cosmic history? Could they be shaping the fate of the universe more profoundly than we ever imagined? The idea that voids are actively expanding faster than the rest of the universe presents an intriguing question. Are they influencing the large-scale structure of the cosmos itself? If galaxies and galaxy clusters are being driven apart by the accelerating expansion of space, could the voids be acting as amplifiers of this process? Some models suggest that voids may serve as natural accelerators, where dark energy's effects are more pronounced, causing space to expand at a faster rate than in denser regions. If this is the case, then the growth of voids could be an essential clue in understanding the true nature of dark energy, whether it is a constant force or a dynamic entity evolving over time. But voids also raise another, more unsettling question. What happens when they grow large enough? Will there come a time when the cosmic web itself is pulled apart, when the last strands of intergalactic matter dissolve into the voids, leaving behind only a structureless, featureless universe? Some cosmologists believe that if dark energy continues its acceleration unchecked, the universe could eventually enter a phase known as the Big Rip. In this scenario, voids would expand so rapidly that even the galaxies, stars, and ultimately the very fabric of atoms themselves would be torn apart by the relentless stretching of space. Yet, voids may also provide an alternative vision of the future. If the universe's expansion eventually slows, if dark energy is not a constant but instead weakens over time, then voids could stabilize, becoming the final large-scale structures in the cosmos. In such a scenario, the last galaxies would find themselves drifting ever farther apart, marooned in an immense cosmic wilderness, surrounded by an eternity of nothingness. And what of the voids themselves? Could they hold undiscovered phenomena, hiding within them elements of physics we have yet to uncover? Some speculative theories propose that voids might be sites where exotic physics takes hold, regions where hidden forces, undetectable elsewhere, subtly shape the universe. Could voids contain remnants of primordial black holes, long since evaporated but leaving behind unseen gravitational imprints? Could they be linked to strange forms of matter or energy, perhaps even housing gateways to other realms of space-time? There is another, even more radical idea. Could voids be illusions of our own limited perception? If our understanding of gravity and space-time is incomplete, then these seemingly empty regions may not be empty at all. Instead, they could be vast, unseen structures, composed of physics beyond the standard model, perhaps even subtle echoes of parallel universes, gravitationally tugging at our own. If true, then voids might be telling us something even more profound, that the universe we perceive is only a fraction of a much greater, much stranger reality. As our telescopes and instruments grow ever more powerful, we are beginning to map these vast expanses with greater precision than ever before. New missions, such as the Vera C. Rubin Observatory and upcoming space telescopes, will allow us to peer deeper into the cosmic voids, measuring their structures, their contents, and perhaps even their hidden forces. Each new discovery reshapes our understanding, forcing us to reconsider what we thought we knew about the cosmos. For now, the voids remain, silent and vast, stretching beyond imagination, their secrets still locked away in the depths of space. But they are not mere absences, they are structures of their own, woven into the very essence of the universe. And as we continue to explore them, we may one day find that they hold the final, most profound truths about the nature of reality itself. If voids are not merely gaps in the cosmos, but instead evolving structures that shape the very destiny of the universe, then their influence may extend far beyond what we currently understand. Could it be that these vast regions of near emptiness are not just a consequence of cosmic expansion, but rather an active force sculpting the universe itself? One of the most astonishing realizations in modern cosmology is that voids are not static. They are not simply leftover spaces where galaxies fail to form. Instead, they are dynamic regions, continuously growing, reshaping themselves over billions of years. As the universe expands, matter is drawn away from these voids and into the surrounding cosmic web, leaving the voids ever larger, ever emptier. This process, known as void evolution, suggests that voids are not just passive regions but active components in the large-scale structure of the universe. Could voids be accelerating the fragmentation of the cosmic web? If they continue to expand, consuming filaments and dispersing galaxies, then the very scaffolding of the universe could one day dissolve. Over trillions of years, the cosmic filaments connecting galaxies may stretch and weaken, until only isolated islands of matter remain, adrift in a universe dominated by vast, cold voids. But there is a deeper question. Do voids interact with the fundamental forces of nature in ways we have yet to observe? Some models propose that voids are uniquely sensitive to the effects of dark energy, the mysterious force driving the universe's accelerated expansion. If dark energy is not uniform, if it varies in strength depending on local conditions, then voids may be where its influence is most pronounced. They could be regions where the very nature of space-time behaves differently, where expansion is not just occurring but accelerating in ways unseen elsewhere. And then there is the question of what voids contain. Are they truly empty, or do they hold structures too faint for us to detect? Some simulations suggest that voids may harbor a hidden network of diffuse gas, faint strands of dark matter, and even rogue planets, worlds that have been ejected from galaxies and now drift unseen through the darkness. Could voids be home to forms of matter yet to be discovered, elements of the universe that do not conform to the physics we understand? Perhaps the strangest idea of all is that voids may reveal the limits of our current theories of gravity and cosmology. If Einstein's general relativity is only an approximation of a deeper, more complex theory of spacetime, then voids could be the very places where these hidden truths emerge. Some physicists speculate that voids may act as natural laboratories for testing modifications to gravity, where subtle deviations from our predictions could hint at a deeper reality, perhaps even evidence of extra dimensions or interactions with other universes. If the universe is not a single isolated entity but part of a much larger multiverse, then could voids be where the boundaries between realities blur? Some speculative theories propose that voids could be regions where our universe has less connection to neighboring ones, cosmic dead zones where the influence of other dimensions is weakest. If this is the case, then voids may not be mere gaps in the cosmic web, they may be barriers, dividing our observable reality from deeper, hidden layers of existence. For now, these are questions without answers. But with each new telescope, each new probe of the cosmic voids, we move closer to unraveling their mysteries. As we map their vast emptiness with ever greater precision, we may find that voids are not just the silent backdrops of the universe, they may be its most essential and enigmatic structures. They may hold the final clues to understanding not only the fate of the cosmos, but the very nature of reality itself. If voids are not mere absences of matter, but regions where the deepest mysteries of the cosmos unfold, then what new revelations might they hold? Could they be the silent architects of the universe's ultimate fate, shaping its evolution in ways we have yet to fully comprehend? The largest voids, such as the Boötes void, the Eridanus void, and the cold spot in the cosmic microwave background, are so vast that they defy conventional explanations. Some span hundreds of millions of light-years, their interiors containing only a handful of galaxies. Their sheer scale raises profound questions. Were they always this empty, or did some unknown process evacuate them of matter over time? If the universe is expanding, why are voids expanding at an even faster rate than dense galaxy clusters? What role do they play in the delicate cosmic balance between expansion, gravity, and dark energy? One of the strangest ideas in theoretical physics suggests that voids may not be passive structures at all. Instead, they could be the very regions where space-time itself is shifting in ways we do not yet understand. Some researchers propose that voids might be home to a unique form of cosmic energy, perhaps a new, undiscovered field that interacts with dark energy, subtly altering the fabric of space. If this were the case, then voids could be windows into new physics, places where the universe's expansion is not just occurring but evolving in fundamentally different ways. But perhaps the greatest mystery is whether voids are as empty as they appear. While conventional wisdom holds that they contain little to no matter, recent simulations suggest that they may house vast but incredibly diffuse reservoirs of gas, remnants of the early universe that never coalesced into galaxies. Could this be where the missing baryons, the ordinary matter that should exist but has yet to be fully accounted for, are hiding? If so, studying voids could provide key insights into the composition of the cosmos, helping to resolve one of the most persistent enigmas in astrophysics. And then there is the question of how voids might influence the formation and evolution of the galaxies that do manage to exist within them. Isolated from the gravitational pull of dense galaxy clusters, these rare galaxies are free from the usual cosmic pressures and interactions that shape most galactic systems. Some astronomers believe that these void galaxies could be relics of an earlier cosmic era, fossils of the universe's youth, evolving along a path that is nearly untouched by external forces. If so, they could provide an unparalleled window into the fundamental processes of star formation and galactic evolution, revealing what happens when galaxies grow in extreme isolation. Yet, some of the most radical ideas about voids challenge the very nature of our universe itself. If voids are growing faster than other structures, could they one day merge into a vast, all-encompassing expanse of nothingness? Could they be evidence of an evolving universe in which, over unimaginable timescales, all structure dissolves into the void? Some cosmologists suggest that in the distant future, the cosmic web itself may unravel, leaving behind only a scattered remnant of galaxies, each alone in an ever-expanding ocean of darkness. There is even the possibility that voids are revealing something deeper, something far beyond our current understanding. Could they be hints of hidden dimensions, places where gravity behaves differently, or where the quantum fabric of space-time is subtly altered? If voids represent regions where the universe interacts least with itself, could they also be places where it interacts most with something else, something beyond our observable reality? As we continue to explore these immense, silent expanses, we are confronted with the profound realization that the universe is not simply a collection of galaxies and stars, but also a realm of vast, incomprehensible emptiness. And in that emptiness, there may be the ultimate answers, waiting to be uncovered in the great cosmic voids. If voids are more than mere cosmic deserts, if they are dynamic, evolving, and perhaps even playing a role in the fate of the universe, then we must ask, what is their true nature? Are they simply the result of normal cosmic evolution, or do they hint at something far stranger, something that challenges the very fabric of our understanding? One of the most intriguing aspects of voids is their apparent ability to shape the movement of galaxies at their edges. The gravitational pull of matter in denser regions creates what is known as a void flow, a phenomenon in which galaxies appear to be moving away from voids as if they are being repelled. But is this simply the result of matter being pulled toward denser areas, or could voids themselves exert a kind of repulsive effect? Some physicists speculate that voids may enhance the effects of dark energy, accelerating local expansion at a higher rate than in other regions. If true, this would mean that voids are not passive regions but active players in the universe's large-scale evolution. And then there is the question of their content. If voids are expanding, what happens to the matter that was once inside them? Some researchers propose that voids may contain ultra-diffuse clouds of primordial gas, the last remnants of a time before galaxies formed. This gas is so thin that it remains undetectable to most telescopes, yet it could account for some of the missing baryons in the universe, the normal matter that has yet to be fully accounted for in cosmological models. If hidden within voids, this missing matter might hold clues about the earliest processes of cosmic evolution, shedding light on how the universe formed its first structures. But voids may also tell us about the ultimate fate of the universe. As they expand, they consume filaments of the cosmic web, erasing structure and separating galaxies. If dark energy continues to dominate, the process may accelerate, stretching space to such an extreme that galaxies become forever isolated, each one alone in an ocean of darkness. In this scenario, sometimes called the Big Freeze, voids will no longer be mere regions between galaxies. They will become the defining feature of the universe itself. Could voids hold evidence of deeper physics? Perhaps even hints of new forces? Some theories propose that gravity might behave differently inside voids, deviating from Einstein's general relativity in subtle but measurable ways. If true, voids could become the best natural laboratories for testing modifications to our understanding of gravity, potentially revealing clues about a deeper, more fundamental theory of the universe. And what if voids are not simply gaps in space but gateways to the unknown? Some researchers have speculated that voids could be evidence of a multiverse, vast regions where our universe interacts least with others. If our universe is part of a larger cosmic landscape, then voids might represent regions where different realities meet, or where our universe is least connected to its cosmic neighbors. Could the laws of physics be subtly different inside voids? Could they be windows into a deeper reality, one that we are only beginning to glimpse? For now, we stand on the threshold of discovery. As our instruments improve, as we peer deeper into these immense expanses of darkness, we may find that voids are not mere absences, not mere holes in the fabric of the universe, but rather the missing pieces in a cosmic puzzle far grander than we ever imagined. And in their vast, silent emptiness, we may find the final clues to understanding the deepest nature of reality itself. If voids are not simply the spaces between galaxies, but are themselves cosmic structures with an active role in shaping the universe, then what ultimate secrets do they hold? Are they remnants of an earlier epoch, scars left by forces we do not yet comprehend, or could they be revealing something profound about the true nature of space and time? One of the most perplexing aspects of voids is their apparent connection to the accelerating expansion of the universe. We already know that the cosmos is expanding, driven by a mysterious force we call dark energy. But recent studies suggest that voids may be where this force is most pronounced. In these regions, where the gravitational pull of normal matter is weakest, dark energy may act more freely, stretching space at an even greater rate than in denser areas. If voids expand faster than the surrounding universe, they could provide a crucial window into understanding dark energy, whether it is a simple cosmological constant, a changing force, or something even more exotic. Could voids be places where space itself is unstable? Some theoretical models propose that space-time is not perfectly smooth, but instead exists in a delicate balance, and voids may be the places where that balance is weakest. If true, voids could be where the first signs of cosmic decay or transformation might appear, subtle clues that the universe itself is not in a permanent state but evolving toward an unknown future. But voids also raise another fascinating question. Are they truly empty? While they lack the bright galaxies and dense matter of cosmic filaments, recent discoveries suggest that voids may contain hidden structures, tenuous strands of gas and dark matter too faint to be seen directly. These ghostly filaments could be the last remnants of an ancient cosmic framework, strands of structure left behind as the universe expanded. If these filaments exist, they could tell us much about how galaxies formed, how matter was distributed in the early universe, and whether dark matter interacts with itself in unexpected ways. And then there are the isolated void galaxies, the few lonely systems adrift in these immense empty spaces. Unlike galaxies in dense clusters, which constantly interact and merge, void galaxies evolve in almost complete solitude. Some astronomers believe these galaxies may represent an alternative path of cosmic evolution, one where star formation is slower, interactions are minimal, and the influence of dark matter is more pronounced. Could these galaxies be cosmic relics, untouched by the violent history of the universe, preserving the conditions of an earlier era? Or could they be something even stranger, galaxies that formed differently from the start, shaped by forces we do not yet fully understand? But perhaps the most profound idea of all is that voids are hints of something beyond, something outside our standard models of physics. If gravity behaves differently inside voids, if dark energy fluctuates within them, or if these regions contain unusual distortions in space-time, then we may need to rethink our understanding of the cosmos. Some researchers have even proposed that voids could be linked to hidden dimensions, where the structure of reality itself is subtly different from what we observe elsewhere. Could voids be places where space bends in ways that allow glimpses of a greater multiverse? Could they be weak points in the fabric of space-time, places where new physics might one day emerge? As we continue to explore these vast expanses, mapping them with ever greater precision, we are not just studying emptiness, we are probing the deepest unknowns of the universe. What we find in the voids may reshape our understanding of the cosmos, revealing the hidden forces that shape reality itself. And in their silent, uncharted darkness, we may yet uncover the final truth about the fate of the universe. If voids are more than just cosmic gaps, if they hold the deepest mysteries of the universe, then what ultimate truths might they reveal? Are they the result of mere cosmic evolution, or could they be windows into forces beyond our current understanding? One of the most profound implications of voids is their potential connection to the true nature of spacetime itself. If space is not merely an empty stage on which the universe unfolds, but an active, dynamic entity, then voids may be the best places to observe this reality in action. Some theories propose that spacetime may behave differently in these vast emptinesses, that the warping of space by gravity, so well understood in the presence of massive objects, may operate in unexpected ways in the absence of matter. If we could detect even the slightest deviation from Einstein's predictions within voids, it could point toward a deeper, more fundamental theory of the cosmos, perhaps even hints of a long-sought quantum theory of gravity. Could voids be portals to the unknown? If they are the places where space-time is least influenced by matter, could they be where the structure of reality itself begins to fray? Some speculative theories suggest that voids could act as regions where our universe's connection to a larger multiverse is weakest, cosmic blind spots where hidden dimensions, unseen physics, or even parallel universes might leave their faintest imprints. If the properties of space-time subtly shift within voids, they might provide indirect evidence of new realms of existence, places beyond what we can currently observe. There is also the question of how voids evolve over time. While galaxy clusters grow denser as the universe ages, voids continue to expand. If dark energy remains constant or even strengthens, voids may one day merge into an all-encompassing vastness, consuming the last filaments of the cosmic web. If this happens, the large-scale structure of the universe may dissolve, leaving behind an unimaginable future in which all remaining galaxies drift apart until they vanish beyond the cosmic horizon. Yet, even in their emptiness, voids may contain hidden matter, structures that have eluded detection. The so-called missing baryon problem, the fact that a large fraction of normal matter expected from the Big Bang remains unaccounted for, could be partially solved if thin, nearly invisible streams of gas exist within voids. If we could detect these structures, we would not only resolve a major mystery in cosmology, but also better understand the unseen architecture of the cosmos. And then there are the galaxies that do exist within voids, scattered like lone wanderers in an endless night. These galaxies evolve in ways that defy expectations, some appearing ancient and passive, others unexpectedly bursting with star formation. Unlike galaxies in crowded environments, where interactions and mergers shape their destinies, void galaxies live in near-complete isolation. Could these lonely systems be relics of a different kind of cosmic evolution, unshaped by the usual forces that govern galaxy clusters? Could they be hints of an alternative path the universe could have taken? Perhaps voids are telling us something fundamental, that the universe is not just a collection of luminous objects, but a vast interplay between presence and absence, matter and emptiness, structure and void. And maybe, in these enormous silent expanses, where galaxies are few and space-time stretches freely, lies the key to understanding not just the universe's past and present, but also its ultimate fate. As our telescopes reach further, as our models grow more precise, the voids of the universe may become our greatest teachers, revealing that even in nothingness, there is something to be learned. And perhaps when we finally understand them, we will have taken the final step toward answering the greatest question of all: what is the true nature of the cosmos itself? If voids are more than just empty stretches of space, if they are fundamental to the evolution of the universe, then could they also be revealing its destiny? Are they expanding toward an ultimate dissolution of all structure, or could they be harboring forces we have yet to comprehend? One of the great unanswered questions in cosmology is whether the universe is ultimately stable. In dense galactic clusters, gravity holds matter together, forming stars, planets, and life as we know it. But in voids, where gravity's influence weakens, could spacetime itself behave differently? Some physicists speculate that voids might be regions of lower energy states, where the very fabric of reality is subtly different. If so, could these vast expanses be where the next great transformation of the universe begins? Could voids, in their seeming emptiness, be the places where cosmic change is set in motion? And what if voids are not entirely empty after all? While conventional observations show little visible matter, new research suggests that voids may contain vast, hidden filaments of dark matter, structures too diffuse to be detected by traditional means. If we could map these filaments, we might not only uncover the missing mass of the universe but also gain insight into how galaxies formed in the first place. Could voids, paradoxically, be the places where the seeds of future cosmic structures are still lurking, waiting for the right conditions to emerge? But there is a more haunting possibility. Could voids be erasing structure, not just passively existing but actively consuming the delicate balance of the cosmic web? If dark energy continues to accelerate the expansion of space, then voids will only grow larger, pushing matter into increasingly isolated regions. Over trillions of years, the last filaments of the cosmic web could dissolve, leaving only isolated galaxies, each alone in a void so vast that no new stars will ever form. If this is the fate of the universe, then voids are not just byproducts of expansion. They are its ultimate expression, the final state of reality as we know it. Yet, there is still the possibility that voids hold deeper mysteries of physics. Some theories propose that gravity itself might behave differently in these nearly empty regions, deviating from Einstein's general relativity. If this is true, voids could be cosmic laboratories, where we might detect subtle signs of new physics, perhaps even evidence of extra dimensions or unknown forces that only become apparent in extreme conditions. Could voids be where the laws of physics break down, where space and time stretch beyond their known limits, revealing something entirely new? And what if voids connect to something even greater? Could they be linked to the multiverse, not just vast empty spaces, but regions where our universe is least connected to others? Some radical theories propose that voids might be the regions where our cosmos subtly interacts with parallel realities, where the influence of unseen universes is weakest. If so, voids may not just be gaps in the cosmic web, but borders between different states of existence, regions where the fabric of space-time is stretched to its limits. For now, we stand on the brink of discovery. With each new observation, each deeper survey, we uncover more about these vast and silent expanses. They are not just the spaces between galaxies. They are the key to understanding everything, from dark matter and dark energy to the fate of the universe itself. Perhaps in the end, the greatest mystery of voids is not that they are empty, but that they may contain the deepest truths of all, truths that will one day reshape our understanding of the cosmos, revealing not only where we are, but where we are going. If voids are not merely empty spaces but the key to the universe's deepest mysteries, then perhaps they are more than we ever imagined. Could they be regions where the fabric of space itself is different, where time flows differently, or where the rules of physics subtly shift? Could they be the final frontier, not of matter, but of knowledge itself? One of the most fascinating possibilities is that voids are not just passively expanding but actively reshaping the universe's structure. As galaxies drift farther apart, drawn toward denser regions and away from these growing cosmic deserts, voids appear to be draining the universe of its order. But what if voids are not just consequences of expansion? What if they are drivers of it? Some researchers propose that voids act as amplifiers of dark energy, accelerating the separation of galaxies and expanding the very fabric of space at an increasing rate. If voids are regions where dark energy is strongest, then they might be influencing the entire evolution of the cosmos more than we have ever realized. And yet, there remains an unsettling mystery. Where is the missing matter? Observations suggest that nearly half of the universe's expected normal matter, the so-called missing baryons, has yet to be found. Some believe that this missing matter is hiding in the faint, nearly undetectable filaments that stretch across voids, forming an almost invisible skeleton of the cosmic web. If these filaments exist, they could reshape our understanding of galaxy formation and cosmic evolution. They could also help answer a deeper question: does dark matter behave differently inside voids? If dark matter is less concentrated in voids, could it mean that its properties change depending on the density of its surroundings? Could voids be places where dark matter decays, or where its interactions follow rules different from those in galaxy clusters? And then there is the question of void galaxies, the few lonely systems scattered within these vast expanses. How do they survive in such isolation? Without the constant mergers and interactions that drive star formation in dense regions, these galaxies may evolve on an entirely different path. Some may be relics from an earlier cosmic era, their stars aging in isolation, untouched by the gravitational forces that shape their clustered counterparts. Others may hold clues about alternative mechanisms of star formation, revealing processes that do not depend on galactic interactions but instead arise from the subtle influence of dark matter and cosmic filaments. Could these lonely galaxies be fossils of a time before structure formed, preserving a glimpse of the universe's early conditions? But what if voids are not just regions of low density, but places where the universe itself is undergoing fundamental changes? Some physicists propose that voids could be where the laws of physics evolve, where space-time is stretched so thin that it begins to reveal its deeper nature. Could voids be places where gravity behaves differently, where quantum effects operate on a cosmic scale, or where the fabric of space-time itself is weaker? If voids are testing grounds for new physics, then studying them could bring us closer to understanding the true nature of gravity, dark energy, and even the origins of space itself. And if voids are expanding faster than the rest of the universe, then what is their ultimate fate? Will they one day merge, consuming the last remaining filaments of the cosmic web, until all that remains is a structureless, uniform expanse? If this happens, the universe may eventually become a vast, cold void, where galaxies are so distant from each other that even light can no longer bridge the gaps. This is the Big Freeze scenario, a future in which voids do not just expand, but become the dominant feature of the cosmos, erasing all structure until nothing remains but endless, formless darkness. But there is also a far stranger possibility. Could voids be hints of another reality? If space-time is not uniform, then perhaps voids represent regions where the influence of other dimensions is weakest. Some speculative models propose that voids could be places where our universe interacts least with others, where the gravitational influence of parallel realities fades into nothingness. If true, voids may not just be holes in the cosmic web, but gaps between different states of existence, where the very nature of reality changes in ways we cannot yet perceive. With each new telescope, each deeper cosmic survey, we are beginning to unravel the secrets of these vast, silent expanses. They are not simply the spaces between galaxies, they are the key to the cosmos itself. They challenge our assumptions, forcing us to confront the unknown forces shaping the universe. And perhaps in the end, we will find that voids are not empty at all, but filled with the deepest, most profound truths of all. If voids are not just vast cosmic deserts but the scaffolding upon which the deepest mysteries of the universe rest, then they may be the most important places we have yet to study. Could it be that these immense regions of near-nothingness hold the final pieces of the puzzle, the key to understanding the fate of the cosmos itself? One of the most unsettling questions about voids is whether they are true emptiness or something more, a kind of hidden structure we have yet to fully comprehend. While galaxies and filaments define the visible universe, voids make up more than 80% of cosmic volume. And yet, they remain the least understood. Some researchers suggest that voids may be filled with invisible forces, perhaps exotic fields of energy, or even a new kind of matter that does not interact in any way we currently recognize. If voids are growing at a faster rate than dense cosmic regions, could they be accelerating the dissolution of the cosmic web? The delicate strands of galaxies that stretch between voids are being pulled apart by dark energy, which itself remains one of the greatest unsolved mysteries of physics. Could voids be the places where dark energy's influence is most profound? Could they hold the key to understanding whether this mysterious force is a constant property of space or an evolving phenomenon? If dark energy changes over time, then voids may be where this shift becomes most apparent, where space itself begins to stretch beyond the limits of what we currently believe possible. And what if voids contain subtle distortions of space-time? In general relativity, gravity bends space, creating the cosmic structures we observe. But what happens in the opposite case, where gravity is nearly absent? Some physicists propose that voids may reveal a new side of gravity, where repulsive effects or unexplored modifications of Einstein's equations become visible. If gravity behaves differently in voids, it could revolutionize our understanding of spacetime, potentially leading to a new theory of physics that unifies gravity with the quantum world. There is also the question of void boundaries. The edges of voids are strange places, where galaxies seem to move outward in a way that suggests they are being repelled rather than simply falling toward denser regions. Could voids contain an intrinsic repulsive force, a property of space itself that has gone unnoticed? Some theories suggest that voids might be regions where space-time expands at an accelerated rate, subtly altering the motion of surrounding galaxies. If true, this could mean that voids are not merely passive regions of low matter density, but active players in cosmic expansion. And then there is the question of void galaxies, the rare systems that exist within these empty realms. These galaxies are some of the most isolated in the universe, evolving with little external influence. Without frequent mergers or interactions, void galaxies might hold the secrets of an alternative path of evolution, one where the rules of star formation, dark matter interactions, and galactic aging are entirely different from those in dense environments. Some of these galaxies are surprisingly large, with extended spiral arms and unusually high levels of dark matter. Could void galaxies be relics from an earlier epoch, fossilized remnants of the universe's infancy? Or could they be prototypes of an entirely different kind of cosmic structure, shaped by the unique conditions of near-total isolation? Yet, the greatest mystery of voids may not be what they contain, but rather what they suggest. If voids are expanding at ever-increasing rates, then what happens when they merge? If the cosmic web continues to fragment, could the universe one day become a vast, structureless sea of nothingness? Some models predict that in the far future, all galaxies will be isolated in immense voids, each separated by distances so vast that no light will ever bridge the gap between them. This is the ultimate fate of a universe dominated by dark energy, a future where voids consume all remaining structure, leaving behind an endless, frozen void. But there is one final radical possibility. Could voids be the remnants of an earlier universe? Some theories propose that voids may be scars left by cosmic collisions, places where a previous iteration of the universe left its imprint before fading into the present. Could voids be the echoes of an earlier cosmos, where previous cycles of expansion and contraction played out on timescales beyond our comprehension? If voids contain subtle imprints of past cosmic events, perhaps in the form of tiny fluctuations in the cosmic microwave background, then they could provide the first direct evidence that our universe is not the first, nor the last, but merely one in an endless chain of cosmic rebirths. With each new discovery, voids become more than mere empty spaces. They become places where the deepest questions of cosmology unfold. They challenge our assumptions about space, time, and the fundamental nature of existence. And as we continue to probe their silent depths, we may find that voids are not just vast, cold expanses, but the hidden foundation upon which the universe itself is built. If voids are more than mere gaps in the cosmic web, if they hold the secrets of the universe's structure, evolution, and perhaps even its origins, then what else might they reveal? Could they be the silent architects of the universe's fate, shaping the cosmos in ways we have yet to fully comprehend? One of the most radical possibilities is that voids are not simply passive regions of emptiness, but instead regions where space-time itself behaves differently. In areas where matter is abundant, gravity dominates, shaping galaxies and clusters into massive cosmic structures. But in voids, where gravity's influence is weakest, space-time may stretch and expand in ways that defy our current understanding of physics. Some researchers propose that voids may harbor subtle distortions in the fabric of reality, revealing how gravity operates on the largest scales. If voids behave in ways that challenge Einstein's equations, they could provide evidence for new physics, perhaps even the long-sought unification of general relativity and quantum mechanics. Could voids be the cradles of a deeper form of cosmic evolution? As the universe expands, the matter is being pulled into dense regions, leaving behind ever-growing voids. But what happens if voids continue to merge and expand indefinitely? Some theories suggest that in the far future, voids could become so large that the remaining galaxies will be trapped inside them, forever isolated from each other. If dark energy's influence increases over time, then voids may consume all remaining structure, accelerating the heat death of the universe, a future where all galaxies are separated by distances so vast that no new interactions, no new stars, and no new complexity can ever arise again. But what if voids are not just growing, but actually creating new structures that we have yet to observe? Some simulations suggest that voids contain vast, hidden networks of gas and dark matter, too diffuse to be detected by conventional means. If these invisible structures exist, they could be the missing link in our understanding of galaxy formation, hinting at a cosmic cycle where matter is constantly redistributed rather than simply disappearing into ever-expanding emptiness. Could voids, rather than being the endpoints of cosmic evolution, instead be regions where a new kind of structure is forming, one not based on ordinary matter but on interactions we do not yet fully understand? And then there is the question of void boundaries, the edges where galaxies seem to flow outward as if being repelled, rather than simply falling toward denser regions. This peculiar motion suggests that voids may exert a kind of anti-gravity effect, subtly influencing their surroundings. Some researchers speculate that this might be evidence of a new force of nature, one that only reveals itself in extreme conditions of low density. If true, this could revolutionize our understanding of the fundamental forces shaping the cosmos. But there is another possibility, one that challenges not just our understanding of voids, but of the universe itself. Could voids be evidence that our universe is part of a larger, unseen reality? Some models suggest that voids may be regions where our universe interacts least with others, where the influence of higher dimensions or even alternate realities is weakest. If voids are places where space-time is stretched to its limits, then could they also be places where the structure of the universe is most fragile, where hidden aspects of reality might become apparent? If our universe is part of a multiverse, a vast collection of cosmic domains, each with its own laws of physics, then voids might be the closest thing we have to natural windows into the unknown. Could these great cosmic voids, in their silence and darkness, be places where the barriers between universes blur, where the edges of our reality dissolve into something beyond? For now, the answers remain hidden, locked away in the cold, dark depths of these vast cosmic expanses. But with every new survey, every deeper probe into the structure of voids, we move closer to understanding the true nature of the cosmos. Void by void, mystery by mystery, we are beginning to grasp a profound truth, that emptiness is not the absence of something, but the presence of a secret waiting to be uncovered. Perhaps in the end, voids are not just the silent spaces between galaxies, but the missing pieces of a far greater puzzle, one that, once solved, will reveal the ultimate fate of the universe itself. If voids are not merely the empty spaces between galaxies, but instead the silent architects of the universe, then they may hold the deepest secrets of cosmic evolution, gravity, and even the nature of reality itself. Could they be shaping the cosmos in ways we have yet to understand? Could they be the hidden forces guiding the fate of everything we see? One of the most perplexing mysteries surrounding voids is their connection to dark energy, the unseen force driving the universe's accelerating expansion. We know that the cosmic web is stretching apart, with galaxies being pulled toward denser regions while voids continue to grow. But why do voids appear to expand even faster than the rest of the universe? Could dark energy be stronger inside these empty regions? If so, then voids may not just be passive structures, but the very places where dark energy exerts its greatest influence. Some researchers speculate that voids are natural accelerators of cosmic expansion, regions where the repulsive effects of dark energy are most pronounced. If true, voids could provide a crucial test for whether dark energy is truly a constant or whether it evolves over time, potentially leading to an even faster expansion in the distant future. If dark energy is dynamic, then voids may reveal whether the universe will continue expanding forever or whether its fate holds something even more dramatic, such as a big rip, where the very fabric of space-time is torn apart at the largest scales. But voids may also contain something far more unexpected, hints that gravity itself behaves differently in these immense, low-density regions. In standard physics, gravity is always attractive, pulling matter together to form galaxies, stars, and planets. But what if voids reveal a missing piece of gravity's true nature? Some alternative theories suggest that at extremely low densities, gravity could become repulsive, subtly pushing galaxies away from voids rather than simply allowing them to drift toward denser regions. If such an effect exists, it would rewrite our understanding of Einstein's general relativity, forcing us to consider a more complex picture of how space-time bends and stretches. Could voids then be the laboratories for a deeper theory of physics? If our current models of gravity fail in these extreme environments, then voids might be the very places where we find evidence of a long-sought unification of gravity and quantum mechanics. Could voids, rather than being simple gaps in the cosmic web, be the frontiers of undiscovered physics, places where the fundamental nature of reality is different from the universe we think we know? And what about the matter that once existed within voids? If these regions once contained more galaxies, where did all the missing material go? Some theories suggest that matter was not merely pulled away, but that voids may have played a role in redistributing cosmic matter, perhaps even forming faint, hidden structures that we have yet to detect. Could these unseen filaments, stretching across voids in delicate, nearly invisible threads, be the last remnants of an earlier cosmic epoch, an age before the current structure of the universe solidified? Then there is the question of void galaxies, the rare systems that manage to survive in these immense, desolate expanses. Unlike their counterparts in dense clusters, void galaxies evolve in extreme isolation, cut off from the usual gravitational interactions that shape most galactic formations. Some appear strangely pristine, with slow, steady star formation that suggests they have avoided the turbulence of the cosmic web. Others appear unusually dark matter-rich, their structure held together by invisible mass rather than interactions with neighboring galaxies. Could these void galaxies be the fossils of a different kind of cosmic evolution, relics of a universe that once behaved very differently from the one we observe today? Yet, perhaps the most radical possibility is that voids are not just regions where matter is missing, but regions where the universe itself is different. Could voids be places where the very fabric of space-time is weaker? Some speculative theories propose that voids might be locations where extra dimensions, hidden from normal physics, have a stronger influence. If so, then voids could be where our universe interacts with something beyond itself, where the subtle pull of an unseen reality distorts space in ways we have yet to detect. And what if voids are more than just structural features of the universe? Could they be the remnants of something before the Big Bang, imprints of a previous cosmic cycle? Some theories suggest that voids could be places where the scars of past universes remain, subtle echoes of a time before our own. If we could detect minute irregularities in the cosmic microwave background within voids, they might reveal whether these vast empty spaces are truly the end of structure, or the beginning of something even greater. With every new observation, voids challenge our perception of the universe. They are not merely the spaces between galaxies, but the keys to the most fundamental questions in cosmology. They force us to ask whether space-time is uniform, whether dark energy is constant, whether gravity itself behaves as we expect. Perhaps in the end, voids are not emptiness at all, but the hidden canvas upon which the deepest truths of the universe are written. And as we continue to probe these immense and silent expanses, we may one day find that the answers we seek have been waiting there all along, in the vast, uncharted darkness of the cosmic voids. If voids are not just empty spaces but the silent forces shaping the fate of the universe, then perhaps they are the hidden key to the cosmos itself. Could they be regions where new physics emerges, where the fundamental nature of space-time shifts, or where the universe's ultimate fate is already written into its vast, dark expanse? The fate of structure. Will voids consume the cosmic web? As the universe expands, voids are not remaining static. They are growing, merging, and consuming the delicate filaments of the cosmic web. Over billions of years, gravity pulls galaxies into dense clusters while dark energy stretches the space between them, leaving behind larger and larger voids. Some cosmologists believe that in the far future, voids will dominate the cosmos, leaving behind only a few isolated galaxies, each alone in an expanding sea of nothingness. Could this be the final stage of cosmic evolution? If the trend continues, there may come a time when all remaining galaxies are so far apart that no new stars will form, no new structures will arise, and the universe will become a vast, frozen void. This scenario, sometimes called the Big Freeze, envisions a universe where the last galaxies are stranded in a featureless expanse of space, separated by distances so great that light itself cannot cross them. But there is another, even more unsettling possibility. What if voids do not simply grow, but actually accelerate cosmic decay? Some theories suggest that as voids expand, they could contribute to the ultimate breakdown of matter itself. If dark energy strengthens over time, it may not just drive galaxies apart, it may tear apart stars, planets, and even atoms in a catastrophic event known as the Big Rip. If voids are the places where dark energy is most dominant, then they may be the first regions to experience this unraveling of reality, where the very structure of space-time dissolves into an unrecognizable form. Are voids windows into a deeper reality? If voids expand faster than the rest of the universe, could they be revealing something even stranger? Some radical theories suggest that voids may not just be the absence of matter, but regions where the fabric of reality itself is thinner. Could voids be places where the influence of other dimensions is weakest, where the boundary between our universe and something beyond is stretched to its limits? Some physicists propose that voids might be places where the effects of a multiverse, if such a thing exists, are most subtle. If our universe is just one of many, then voids might represent regions where our reality interacts least with others, where the cosmic influence of parallel universes is weakest. If this is the case, could we one day use voids as natural observatories to test whether our universe is truly alone, or whether it exists as part of something much larger? And then there is the question of gravity itself. Einstein's general relativity has been tested in extreme conditions, near black holes, in high-energy cosmic collisions. But what if voids offer the opposite extreme? Could gravity behave differently in a place where mass is nearly absent? Some models suggest that at extremely low densities, gravity may not act as we expect, hinting at a deeper, more complex structure to spacetime. If voids reveal even the slightest deviation from Einstein's equations, they could provide the first evidence of a theory of gravity that goes beyond general relativity, bringing us closer to unifying gravity with quantum mechanics. The mystery of hidden matter. Do voids hold the last clues? Another persistent puzzle in astrophysics is that nearly half of the expected baryonic matter in the universe, the normal matter that makes up stars, planets, and gas clouds, is missing. Some researchers suspect that voids might be hiding it, in the form of diffuse, undetectable gas or exotic matter structures. If true, voids could be the final missing piece in our understanding of how matter was distributed after the Big Bang. But there is another more exotic idea. What if voids are places where dark matter interacts differently than expected? Some alternative theories propose that dark matter may decay over time, and if so, voids, where matter density is lowest, may be where these effects are most visible. If we could detect even a slight variation in how dark matter behaves inside voids versus in galaxy clusters, we might finally unlock one of the greatest secrets of cosmology: what dark matter truly is. Could voids be cosmic relics from a past universe? If voids are the largest and oldest structures in the cosmos, could they be imprints of a universe that came before ours? Some cosmological models, including cyclical universe theories, suggest that our cosmos may have undergone previous cycles of expansion and contraction, epochs where entire universes formed, evolved, and eventually collapsed before being reborn in a new Big Bang. If voids contain subtle imprints of these past cosmic cycles, they might provide evidence that the universe did not begin from a singular point, but rather emerged from an eternal repeating process. Some researchers have even suggested that voids may contain subtle distortions in the cosmic microwave background, leftover signals from previous iterations of the universe. If voids are scars from past cosmic events, they could hold the ultimate proof that our universe is not the first, nor the last, but one of an endless series of cosmic rebirths. The future of void research. What lies ahead? In the coming decades, astronomers will use advanced telescopes like the Vera C. Rubin Observatory, the Nancy Grace Roman Space Telescope, and next-generation radio arrays to probe voids with unprecedented precision. With these tools, we may finally answer the biggest questions about voids. Do they contain undiscovered forms of matter or energy? Is gravity different inside voids, hinting at new physics? Are voids influencing the universe's expansion more than we realize? Do voids contain hidden signals from previous universes? Every great scientific discovery has required looking into the unknown, questioning the nature of reality itself. Voids, once thought to be empty nothingness, may instead be the most important structures in the cosmos. They may hold the final clues to dark matter, dark energy, and even the multiverse itself. Perhaps in the vast silence of these cosmic voids, the universe is whispering its deepest secrets, waiting for us to finally listen. If voids are not just the empty spaces between galaxies, but instead the silent forces shaping the destiny of the universe, then they may hold the final ultimate truths about the cosmos. Could they be the laboratories of dark energy, the hidden keys to gravity, or even the scars of a universe that came before our own? Are voids the architects of cosmic evolution? As the universe ages, its vast structures continue to change. Galaxies drift apart, clusters collapse under gravity, and stars are born and die. But voids, the great cosmic deserts, only grow larger, swallowing filaments of the cosmic web as space itself expands. If we could watch the universe unfold over hundreds of billions of years, we would see voids gradually erase structure, stretching matter thin until only a few isolated galaxies remain. Could this process accelerate as time goes on? Some cosmologists suggest that voids may amplify the effects of dark energy, meaning that expansion is not just occurring but intensifying within them. If so, then voids may be far more than passive regions of low density. They may be active engines driving the expansion of space itself. If dark energy increases over time, voids may eventually consume the entire cosmic web, until nothing remains but an endless, formless void. But there is an even more perplexing question. Is there a limit to how large a void can grow? If voids continue expanding indefinitely, they could become the dominant feature of the universe, erasing all recognizable structures. Some researchers speculate that voids could eventually reach a critical size, beyond which space itself may become unstable. If this is true, then voids may not just consume structure, they may also rewrite the physics of space-time at the largest scales. Are voids the missing link between dark matter and gravity? One of the great cosmic mysteries is whether dark matter behaves the same way inside voids as it does in dense regions. Standard models assume that dark matter is a simple, non-interacting substance, but what if its properties change depending on its surroundings? If dark matter interacts differently in voids, it could reveal entirely new physics, perhaps even the long-sought explanation for why galaxies behave as they do. Some radical theories propose that voids might be places where gravity itself behaves differently, revealing subtle deviations from Einstein's general relativity. If we find that galaxies at the edges of voids move in unexpected ways, it could mean that voids are warping spacetime in ways we have never seen before. Could voids be places where an alternative form of gravity emerges, one that only becomes apparent in the absence of mass? Do voids contain hidden energy? Another possibility is that voids are not truly empty but are instead filled with exotic forms of energy. Some models suggest that voids could be home to vacuum fluctuations, quantum ripples in spacetime that normally cancel out but might become more pronounced in low-density regions. If voids are amplifying these fluctuations, they could be natural laboratories for quantum gravity, helping us bridge the gap between the physics of the very large and the very small. This leads to an even more astonishing idea. What if voids are places where new universes could be born? Some versions of inflation theory suggest that the universe itself may have emerged from a quantum fluctuation in a vacuum, meaning that voids, where similar conditions might exist, could be places where new Big Bangs might one day occur. If this is the case, then voids are not just the end of structure, they may also be the beginning of something new. Are voids the last remnants of a previous universe? If voids are so large, so old, and so empty, could they be the remnants of a cosmic event far older than the Big Bang itself? Some speculative models of the universe suggest that voids might be the places where traces of previous cosmic cycles remain. If the universe has undergone multiple births and deaths, then voids may be the scars of a past universe, places where the last echoes of a previous cosmos still linger. Could voids be revealing evidence that the universe is not a one-time event, but instead part of an eternal cycle? If we detect unexpected temperature fluctuations in the cosmic microwave background near voids, they could be the first signs that voids are not just regions of low density, but the faint imprints of something older than our universe itself. Are voids the borders of the multiverse? One of the most radical possibilities is that voids are not just vast empty spaces, but the places where our universe is weakest, where the fabric of reality itself is stretched to its limits. If the multiverse is real, then voids might be the borders where our universe interacts least with others. Could voids be places where space-time is subtly influenced by neighboring realities, where the laws of physics begin to shift? Some researchers suggest that voids might even be where the edges of universes touch. If our cosmos is part of a larger structure, then voids could be places where the effects of other dimensions become most apparent. Could the subtle gravitational distortions we see in voids be whispers from other universes, imprints of cosmic realms beyond our own? The future of void exploration, unlocking the final secrets of the cosmos. The next generation of astronomical surveys will allow us to study voids in unprecedented detail. Missions like the Nancy Grace Roman Space Telescope, Euclid, and the Vera C. Rubin Observatory will map voids with extraordinary precision, revealing whether they contain hidden structures, unseen matter, or even evidence of new physics. With these tools, we may soon answer the biggest questions about voids. Are voids accelerating the expansion of the universe? Do voids contain undiscovered forms of matter or energy? Is gravity different inside voids, hinting at new physics? Are voids scars from previous cosmic cycles? Could voids be places where the multiverse leaves its imprint? Each discovery will bring us closer to the ultimate revelation, whether voids are simply cosmic empty spaces, or whether they are the deepest, most profound structures in the universe, the silent architects of reality itself. Perhaps in the vast silence of these cosmic voids, the universe is whispering its deepest secrets, waiting for us to finally listen. The final truth of the cosmic voids, the great voids of the universe, once thought to be mere gaps between galaxies, have revealed themselves to be far more profound. They are not simply empty spaces, but living, evolving structures that shape the very fabric of the cosmos. From the mysterious influence of dark energy to the subtle distortions of gravity, voids may hold the final keys to unlocking the secrets of the universe. As they expand, they may be guiding the cosmos toward its ultimate fate, perhaps an endless big freeze, where structure dissolves into nothingness, or an even stranger big rip, where the very fabric of space-time is torn apart. They may be gateways to new physics, places where gravity behaves differently, or even the scars of a universe that came before our own. Some theories even suggest that voids could be the borders of the multiverse, where the edges of our reality dissolve into something beyond comprehension. With each new observation, each deeper probe into these vast and silent expanses, we move closer to the ultimate realization that voids are not simply the absence of matter, but the presence of a deeper cosmic truth. They may be the dark canvases upon which the destiny of the universe is written, the silent architects shaping the very nature of existence. And perhaps when we finally unravel their mysteries, we will come to understand that emptiness itself is not empty at all, but filled with the greatest secrets of the cosmos.